Hello everyone and welcome back to C# Advanced Tutorials. My name is Steve Bishop, and in this video we're going to take a look at delegates and events. So the typical programming flow would be where we call one function from another. And this works great when you're dealing with synchronous processes, where you can just call one command right after another. But things get a little trickier out in the real world. Sometimes we have certain services that don't respond right away, but we don't want to lock up the user experience. We don't want to have to force them to answer every one of our questions whenever it happens. And you can think of a UI as a perfect scenario. We want to handle whenever a button is clicked or somebody types something in the text box. For that, you need to have some sort of delegate. So in this diagram, what we actually have is a reversal of the dependency. The post back delegate is being raised by the post function, and that post back delegate receives a hello back string, and we've wired up in our program class for the post back delegate to call the onPostBack function. And the onPostBack function receives that message as a parameter and writes it to the console window. The important thing to note here is the reversal of the dependency. Instead of calling the post function and assuming that the post function is going to call the console.writeLine, instead we're saying, hey, when you're done doing whatever you're going to do in that post function, I'm going to be listening in case you have anything to post back. And when you do post something back, I'm going to write to the console window. Let's go ahead and hop into some code and start working with some delegates and events. So for this demonstration, I've decided to go ahead and slim things down to just using Visual Studio Code and not the full Visual Studio IDE. I kind of want to make things simple so we can focus just on the code. Now to do this, I'm going to go ahead and change directories to my projects folder, because that's where I like to do all my projects. And I'm going to go ahead and make a directory of C# delegates. Let's go ahead and change directories into that C# delegates. And let's make a new .NET application of type console. All right, now we can just go ahead and open that folder up. So we'll do open folder, and we'll just select C# delegates. And I'm going to close the welcome screen, but open the program.cs file. And now this is in just a moment going to say that it needs to do some compiling of some stuff in the background for me and building, and we're going to go ahead and click yes. That's fine. Okay, now I'm going to go ahead and remove this console.writeLine of hello world because we're not going to need it for this demonstration. So the first thing I'm going to go ahead and do is create a new class. So we're going to do new C# class, and we're going to call this Math Service. Now in our Math Service, I'm going to provide a couple of functions that are going to add and multiply two numbers together. So we're just going to go ahead and do a private function, and that may surprise you, but we're going to do a double as a return type of add numbers is the name of the function, and it's going to receive two parameters of type double. So we'll call these value1 and value2. And of course, as you may have guessed, we're going to return value1 plus value2. All right, let's go ahead and create another private double multiply numbers function that receives double value1 and double value2. All right, and of course, it's going to return value1 times value2. Okay. Now, obviously, these are private, and so I can't really call them. Even if I go over here to my main method and I do math service, call this service, and we'll set it to a new math service. But of course, if I tried to call on service.add or multiply numbers, nothing's going to show up. So that's not going to work. Let's go back to our math service here. What I'm going to do is I'm going to add a delegate to this math service. So up at the top here, I'm going to add a public delegate. I'm going to have the return type of double, and I'm going to call this result handler, and it's going to receive double value 1 and double value 2. You may have noticed that this matches the same signature of what I have for add numbers and multiply numbers, and that's on purpose. A delegate is much like an interface. Interfaces in the C# language define what the members of a class should be. So what should be the members and methods and properties of a class. A delegate is doing exactly the same thing, but it's for a function. So if we want to say that a particular function must be of a type result handler, then it needs to match the output and inputs of our delegate. So it's really helpful, I think, to think of delegates as a very small interface. They define what a function should take in and what it should return. But notice that there is no actual functionality being implemented here. Again, just like interfaces. Interfaces don't define the functionality. They just define the signatures of those properties and methods. Now, since we've defined this delegate called result handler, but we don't actually have an implementation of the result handler, then we need to go ahead and add a property on here of type result handler. And I'm going to call this the MathDelegate. So my MathDelegate property is an instance of result handler. Oh, well, rather it's a property of type result handler. We haven't actually added an instance yet. And I just kind of want to show that here. If I try to actually run this application, well, first let's go ahead and call service.MathDelegate. Notice that MathDelegate is now callable. So if I try to do 4.5 and 5.78, that this is callable, right? So MathDelegate works just like the add numbers and multiply numbers. It's kind of like a go-between, right? It's one of these things that we call a contract. So I can call MathDelegate, I can pass along some values to it, but when I try to run this, .NET run, when I try to call it, we're going to get an error that we have a null reference exception. So we need to actually set this MathDelegate property to some instance of type result handler. And you may think that the best way to do that would be to go here and say new result handler, but we're going to have a problem. And you're just going to see that a result handler does not contain a constructor that takes 0 arguments. So we need to pass into this result handler an argument. But what kind of argument? Well, what it needs to take in is actually the name of the function that is going to be assigned to the MathDelegate. So I'm just going to say add numbers. Now, that does raise another problem, though, and that is the add numbers function is not actually something that can be referenced in this way. It's not a field initializer cannot be referenced with a non-static field, right? Because these are not statics. So what I need to do is actually create an instance that I can then refer to. And I'm going to do that using the constructor. I'm going to say math service. And now that I have an instance of the math service up and running, once the math service is called, now I can refer to either the add numbers or multiply numbers functions on that math service. So I can say, I'm going to move this assignment. Oops, not the whole thing, just copy. There we go. And we're going to remove the assignment operation there to there. Now, it may not seem like I really did anything there, but really what's happening is because the math service constructor is happening means we're inside of an instance of the object that is of a type math service. And that means that the add numbers and multiply numbers are something that are assignable. Now when I go ahead and try to run the same thing, do .NET run, and we're just going to get back nothing, right? Well, that's because we're not really doing anything with that result, right? So we're calling MathDelegate, but we're not doing anything with the return values. And there is a return value. Notice that the result handler is actually going to return a double. So our MathDelegate is going to return a double. So let's go ahead and assign that return value to a result. And we'll do a console.writeLine of that result. And we'll see what we get. All right, our result is 10.28. That sounds about right. So what did you really gain from this? I mean, why didn't we just set these add numbers and multiply number functions to public? Well, one of the cool things that you've actually gained is that add numbers and multiply numbers are encapsulated. And we can swap the behavior of the MathDelegate just by changing what it's being referenced to. So now I can change the behavior of this delegate to instead run the multiply numbers function when it's being called. So if I do .NET Run, our result is going to be 26.01. So we can change the implementation that goes along with our delegate. And that is the whole purpose of an interface as well. Again, I'm going to probably make this reference regularly between delegates and interfaces because they're really the same thing, just on a smaller scale. So we've changed the behavior behind the delegate, and that means we have this encapsulated or black box, if you will, of how this math service is supposed to behave. And the program class doesn't really care what that math delegate is doing, just so long as it returns a result and I can write that to the console window. So we can change the business rules behind the scenes without affecting its implementation. And that is a really critical part of having a long-lasting application. So that's cool, but didn't I show you in the slides how we had some sort of dependency inversion where we were instead going to do something inside of our program class that was going to be called and our math service was going to be returning something? Well, let's go ahead and do that now. I'm going to go ahead and create another delegate. This one is going to be returning a void. So it's not going to return any actual data type. We're going to say outbound handler. But what I am going to do is I'm going to pass as a parameter to it a double that is going to be the result. And what I'd like to do is have this outbound handler hand off the result to anybody that's listening. Now, again, a delegate, just like an interface, needs to be implemented, so I need to add a property on here. I'm going to say outbound handler, and we're going to call this outbound delegate. And I need to change what the behavior is of our add numbers and multiply numbers. Instead, what I need them to do is not just return those values, but actually send them to our outbound delegate so that if anybody is listening to this outbound delegate, they will receive the results of the calculation. So to do that, I'm going to actually call outbound delegate, and I'm going to pass in value 1 plus value 2. Now, this seems like a little extra here. I'm just going to be returning the same results of the calculation. So let's just stuff these in some sort of result. And we'll just return the result. And just for keeping things simple, I'm going to copy this and do the same thing down here for our multiply numbers, but I'm going to change that to a multiplication calculation. And now our add numbers and multiply numbers functions are going to both raise the outbound delegate, passing along the result of the calculation. So once again, just to walk you through this, the outbound delegate is going to be raised with the value of the calculation being passed as a parameter. And we have an outbound delegate here. It's called outbound handler. So we have a delegate called outbound delegate of type outbound handler. And now we need to wire it up so that if anybody wants to listen to that outbound delegate, then they will receive the result of the calculation. So let's go back to our program class here. And now I'm going to go to my service here, and I'm going to say on the service, I'm going to be listening to that outbound delegate. Now, what am I going to assign to it, though? That's kind of a problem, isn't it? I need to assign something to this outbound delegate, a function that, if we recall, is defined by the outbound handler delegate here to be a return type of void, but takes in a double. So I need to go ahead and create a function on my program class. It's going to be a static void, and of course void because that's the definition for the delegate. And I'm going to call this on outbound delegate. And again, it's going to receive a double that will be the result. Now, what do we want to do with that result? Well, we're just going to do console.writeLine. We're going to say outbound result is going to be that result. So now it's not up to the math service to figure out what to do with that result, right? It's just sending that out through this outbound handler delegate, which is really the outbound delegate property here. And we're going to be taking that result here and writing out to the console window, which means I don't really need it here anymore, do I? So I'm going to drop all that. And I'm going to assign to the outbound delegate. And I might be tempted to say new of type delegate, right? We got this outbound handler delegate. But what we actually can do is something really cool. In the C# compiler, it'll figure out that we're wanting to do a new instance of the delegate if we just simply assign the outbound delegate function to the outbound delegate property of the service. So I don't need to do this whole new, like we did with result handler. I don't need to do a new outbound handler. I could just simply assign the actual function straight to the outbound delegate. Now right now, if I go ahead and do .NET Run, nothing's really going to happen here. That's because we still need to, at some point, cause the add numbers and multiply numbers function to run. Now, you can imagine this might be some sort of trigger, some sort of event that somebody clicks on a button or does something, but in our case, we don't have something that simple to do with, so we're just going to go ahead and re-raise on service dot MathDelegate. We're going to call and pass along 4.5, and this time we're going to change the value to 9.3. We'll do even 9.38. Why not? Now when we do .NET Run, we're going to see outbound result, 42.21. Now again, this may seem like nothing significant has really happened, but I'm going to show you something that's really, really cool about delegates, and that is they are multicasting. What do I mean by multicasting? Well, remember back here on our MathDelegate, we were assigning a single multiply numbers. And we also learned that we can just simply do this assignment like this instead. We don't really need to make a new instance of that result handler. So I can just go ahead and change this. But I can also add another function to call. So I can say on MathDelegate, I'm going to add the add numbers. So now the MathDelegate, when it gets raised, will call both multiply numbers and add numbers. And both add numbers and multiply numbers, in return, call the outbound delegate. So they're both going to return their results. And back here in our program class, we've assigned to the outbound delegate the function of onOutboundDelegate that each time that it gets raised to go ahead and call WriteLine to the console window. So now when we do our .NET Run, we're not just going to see the result of one calculation, but we're going to see the result of both of them. And now we have successfully reversed the dependencies. Now the math service is doing its calculation and returning it back to our outbound delegate, but it doesn't really care who's listening. If you happen to be listening, great. But if you're not, oh well, I'm still going to do what I do. And that's precisely the same behavior you might see with a user interface. When a user clicks on a button or types something in a text box, you don't necessarily always have every single event captured. You only wire up the things that you want to have wired up. So, this probably sounds a lot like events, doesn't it? You may have heard the term event, and you're looking at these delegates going, well, isn't that basically just an event? And that's absolutely right. That's exactly what's going on. Delegates and events go hand in hand. And so far, we've been using this outbound delegate, and we've said it needs to be of a type outbound handler. But I'm going to add, on top of this, we're going to say a public outbound handler, but we're going to call this an outbound event. Now, technically, we need to add the event keyword here to make this a proper event. Now that we've done that, these two things are essentially identical. So I don't need the old one. Let's go ahead and get rid of it. We'll drop it. And we, of course, need to change our names here because these are no longer calling outbound delegate. They're going to be calling outbound event. Now, the change in making that happen, notice that I can call or raise the outbound event, and we get a new little lightning symbol here indicating that this is an event that we are raising. And that's one of the benefits of changing these over from delegates to actual events. We're being very specific that these are events now, and our IDEs are really good at picking that up and kind of showing us that that's what's happening. So if I go back here, again, we change the outbound delegate to be the outbound event. And we see, once again, the lightning bolt. And this helps us in our experience. But what's going on here? The outbound event can only appear in the left-hand side of a plus equals or minus equals. Well, all we have to do to fix that is add a little plus sign. So now let's run our application again. Would you look at that? An event is basically just the same way we handle delegates. Now, one last thing I would like to change, though, is since we're no longer calling it outbound delegate and instead change the name to outbound event, I'd like to also change the name that we use here to on outbound event. Now, this is following a naming convention you may have seen when you've looked at code that deals with events. I've been intentionally following this naming convention all along the way to help you understand what that convention is and get it into your brain as early as possible. Here we are calling all of the delegates that handle our events with the suffix of handler. And we name all of our events with the suffix of event. And any function that is going to be assigned to one of those events begins with the on keyword. So on is the prefix, event is the suffix. And any delegate that we use is suffixed with handler. Now, it's not totally necessary to do this. It's just a convention that we use as developers to help us identify what the purpose of each function, delegate, and property is. So now that we've demystified events in C#, let's take it one step further. You may have thought, well, would there maybe be some sort of standard event in the Microsoft C# library? Well, absolutely there is. So I'm going to go ahead and comment out all of our delegates and events that we've put on our math service. And what I'm going to put here instead is a new public event, and it's going to be of type event handler. And I'm going to call this math performed. Now, I need to bring in the namespace. It's just the system namespace. So if I just do control period, bring in using system, then it seems to like event handler just fine. Now, what I also need to do with this event handler event is I need to send in a data type. So we're going to do that using a type parameter. Now, that type parameter needs to be a class that inherits from the event args class. So I need to go create another class that inherits from event args. So let's go ahead and right click and create a new class. I'm going to call this class math performed event args. And we're going to inherit from event args. Let's go ahead and open up the IntelliSense here to bring in using system. And now on our math performed event args, I'm going to specify a couple of properties on here. Actually, all I really need is just one. So we're going to do public double math result get and set. And I'm going to do a constructor function here just to make things simpler when I create one of these. And we're going to take in a double. I'm going to call result, and I'm going to set the math result to that result that's passed in. Simple enough. So we created our math performed event args, and we can change now the data type here for our event handler as the type parameter for our event handler to the math performed event args. Now I'm also going to go ahead and take away the constructor here because we don't need this anymore. And I'm going to turn these add numbers and multiply numbers into public just because I'm going to make them easier to access and kind of slim down what we're doing with our code here. In fact, I think I'll go ahead and just remove all this commented out code to make things smaller. All right, now, instead of calling outbound event, because that's no longer there, we're going to call math performed. So we're going to say math performed. But the math performed function requires that I pass to it some sort of instance of math performed event args. So instead of just passing in a result like this, I'm going to create a new math performed event args, and I'm going to pass that result value onto those math performed event args. Now, the other thing that I need to pass along to an event handler that is standardized is not just the event args, but also it needs to have a reference to the sender. So I'm going to pass along this as the sender. This is a reference to the math service. Now that's just really kind of an artifact of the event handler event. It's a standardized event process where we receive who it is that's actually calling the event, and we receive information about whoever that is, so that if we wanted to inspect some of the values or the ways that this math service function works inside of whatever is handling that event, then we might want to see those type of details. But along with that, we also need to pass along those arguments, those math performed event args. And that math performed event args is where we're going to find the actual results of our calculation. Let me just go ahead and take this same line of code here, and I'm going to paste it over our outbound event. And now we have standardized the add numbers and multiply numbers to both use this standard event handler event type of type math performed event args. And we're going to now need to change the way that we're actually consuming this on the program side. So now on our service, we don't have outbound event anymore. We have math performed. Now remember, the data type of the function needs to match whatever it is that the delegate is defined as, or in this case, the event is defined as. So I need to change on my on-outbound event from receiving a double result to receiving an object and an event args, or more specifically, the math performed event args. So let's go ahead and actually, I just want to copy this because that's kind of a long name. So we'll say the second parameter is going to be, oops, try that again, copy. Data type is math performed event args. We're going to call this args. And what we get for the first item is going to be just the object as sender. And now you can see that the error went away on line 10 because the signature of our on-outbound event matched the signature of an event handler. All right, so now that we're good with that, we want to change this from results to args.results, or result, right? Or math result is actually what we called it, isn't it? So let's fix that. And now instead of calling a MathDelegate, let's actually call our add numbers. And our add numbers function, once again, is going to raise the math performed event. And of course, the event is being subscribed to over here on line 10 and saying whenever the math performed event is raised, we're going to call on outbound event. We're going to receive the sender, and we're going to receive the math performed event args. Now, if we do a .NET run, all right, 13.88. And if we go ahead and do service.multiply numbers, and we'll do 5.79 and 12.3. Run that code. And now we'll see the results of both the addition and the multiplication. So this is pretty cool. We have a standardized way of passing along events using these event args class or some sort of extension of that event args. We're using math performed, and we're using the event handler data type, and we don't even need to define the delegate, right? We've eliminated all that extra code because we're using a standard event handler. But I'd like to take this one step further. And I'm going to show you something really cool that we can do now that we have kind of a standardized way of raising events on things. And I'd like to combine this with our knowledge of interfaces. So let's say that for each one of the times that our math is performed, we want to actually log it and notify it. So we want to kind of wire up two other services to this math service. So when the math service is done doing its calculation, we're going to print out the results into two different other services. So we're going to take one service and we're going to wire up two other services. But I want to do this in a very open way. I want to make this something that we could expand upon even later. So maybe we want to add a third or a fourth or a fifth service to respond to every time the math performed event is raised. And when we're talking about systems that are very large and have lots of different moving parts, you can see how this is a practical application of the knowledge that you have. You may have one service that when it is done needs to call a bunch of other services. We're going to utilize an interface to make this happen. So I'm going to go ahead and make a new C# interface, and I'm going to call this iMathPerformed service. And on the iMathPerformed service, I'm going to define a function, void onMathPerformed, that's going to match essentially what we have in our math service for the event handler, right? We have this signature that is required, right? We know about that signature here when we defined on outbound event that we need to receive object sender and math performed event args. And in fact, what I'm going to go ahead and do is just copy this, and I'm going to paste it in our iMathPerformed just so that I have something to compare it to. And I'm going to say, instead of on outbound event, I want to do on math performed. So we'll just copy this, paste it there, and we'll remove the initial attempt here to write the code. All right, so now we have this interface defined with a on math performed function that receives sender and args. So as long as we have a class implementing iMathPerformed service, we know that on that class, it must have an onMathPerformed function that receives a sender and args, but returns void. So let's go ahead and write up a couple of classes that do this. I'm going to make a new class called logging service. And this is going to implement iMathPerformed service. Let's go ahead and do control tick, or control period, and we're going to implement the interface. And instead of throwing a not implemented exception here, let's go ahead and just do a simple little console.writeLine. Console. Oh, I'm missing system, aren't I? Let's bring in system. Oop. Console.writeLine. There we go. And we're going to do logging result. And this time we're going to take args dot math result. All right, good. So that's going to be our logging. And you can obviously imagine this is going to have some other type of implementation other than writing to the console window. It's going to write to some files somewhere or, some sort of event tracker system. Okay, so let's go ahead and add another C# class. This one's going to be called the notification service. And it too will implement iMathPerformed. There you go. Boy, I already knew exactly what I was going to type. All right, implement the interface. And this time, let's go ahead and get rid of the not implemented exception. And what we're going to do is we're going to do a console.writeLine. And again, we need to bring in the system namespace. Right, WriteLine. And we're going to say notification. Result is args.mathResult. Oops, mathResult. MathResult. Come on, math. There we go. All right. So now we have two classes that both implement the iMathPerformed service, and they both have the onMathPerformed function on them that returns void but takes in the sender and the MathPerformed event args. All right. So now let's go back to our program class, and we're going to change a lot of this. What we're going to do here is we're going to say instead of this onOutbound event, we don't need this because now we actually have two services. We have a logging service and a notification service that's going to write to the console window. So I don't need that in my main or in my program class anymore. And instead what I'm going to do is I'm going to make a new list. I need to bring in a namespace for this to work. So bring in that system collections generic. But the list is going to be of a type iMathPerformed service. And I don't even need to make a variable here because what I'm going to do is I'm going to do a new logging service, create an instance of that, and a new notification service. And now we have the logging service and the notification service in my list, and I'm going to call the for each method that we learned about in the last advanced C#. And on this, we're going to say for each service, I want you to wire up to service.mathPerformed. We're going to do the plus equals, and that serve is going to be on MathPerformed because we know that all of those services are going to have that on MathPerformed function defined on them. And so we can just say for every time that MathPerformed event is raised, I want you to wire up each one of my services for that on MathPerformed function to be called on each one of those services whenever the MathPerformed event is raised. All right, so now let's go back here and we're going to do service dot. Let's do add numbers. We'll say 5.79 and 13.2. And we'll do a multiplication as well. So we'll do service.multiply numbers. We'll say 6.29 and 2.05. I'm just throwing out some random numbers. Okay. Now when we do a .NET run, we're just calling the functions, and look at that. Both times the add numbers function and multiply numbers functions are called, we can see that we get both the logging and the notification services printing out to the console window each time. And we can expand upon this, right? We can add more notification services that implement iMathPerformed service, and we're using the ability to just raise those events at any time. That's pretty cool. So we've used our knowledge of how we can use interfaces, of delegates, of events, to really create some cool functionality here where the main function doesn't even know that we're writing to the console window. It doesn't have to care about those implementation details. All it's doing is spinning up an instance of the service, and it's wiring up that Every time one of that math performed events is raised, it's going to call the onMathPerformed function on each one of those services. And now we just have to actually say, hey, go do this stuff. And hey, by the way, when you get done, let's go ahead and log it to the console window. So there we go. All of that is really good information. I hope you guys enjoyed this video. Delegates can be a real fun tool when you really start to get comfortable and use them. I will also make this code available for you to peruse at your own on your own time. It's going to be up on the GitHub repository, and I will post the link in the description below. So if you guys have any additional questions, please feel free to reach out to me in the comments section below. I always love hearing those comments, and I can't wait to see you guys in the next video. Thanks for watching.